Hello boys and girls, Mr. Giomini wanted to come to you with a quick video on the con skill that you're responsible for this evening. Now, before I really get in the video, to be honest with you, these two videos right down here, especially this area of a kite, is an excellent video to watch. Really goes in depth as to why the formula for the area of a kite works. And actually the formula for the area of a kite is very comparable, or is the same formula that you'd use to find the area of a rhombus. But let's take a look. You're going to be fine. If I look at the skill here, it says area of trapezoids, rhombi, and kites. Rhombi is just the plural of when you have multiple rhombuses. They couldn't call it rhombi. Now, first thing I need to do is identify what this shape is, because it's one of these three. Now, looking at this, I see that it has these little markings here indicate that this is a set of parallel sides. So it has one pair of parallel sides. When I think of parallelograms, it has two sets of parallel sides. This only has one. This is a special quadrilateral called a trapezoid. Now, if you recall, and I always like to start with the formula. Formula for every trapezoid is base 1 plus base 2. We cut that in half, and then we times it by the height of the trapezoid. Looking at this, we have the bases are opposite of each other. I see that this is one base, this is the other base. They are opposite each other. We have 2 plus 3, and the bases are the sides that are parallel to each other. So if I think about it, this side will continue on forever in this direction, both directions. This side will continue on in this direction both forever. They will never intersect. Looking at these, if I were to connect these eventually intersect. Those would not be the bases. So taking a look at now my work, I have base 1 plus base 2, which in this case we identified as 2 and 3, or excuse me, 2 and 5 being the bases. 2 and 5, not 2 and 3. I am looking at 3. It is 2 and 5. And then we would divide that by 2 and times it by the height of the trapezoid, which in this case is 3. We have 2 plus 5, which is 7. Divide that by 2, multiply it by 3. Well, I could change this mixed number. That would give me 3.5. 3.5 times 3. Let's see, we have, that's 9. We have, that's 15. It's 1.5. So we have the 1.5 plus the 9 gives me, let's see, is that 10.5? I'm thinking. Let's take a look. Okay. Now, take a look at this. This is actually what we call a rhombus. The reason I know this is we have each side, these are the congruency marks, each side being congruent. We also have a diagonal going from one vertice to a non-adjacent vertice, so that becomes a diagonal. The formula for this would be, it would be 14 times 6. We divide that by 2, or 1/2 of 14 times 6. Because this is multiplication, I could even do, hey, what's half? I can multiply 1/2 times 14 and then times that by 6 if I so desire. I kind of like this a little better because I can really easily find half of 14, which is 7, and I just go 7 times 6, which gives me 42. I see these parallel markings here. Notice the difference. This would indicate that they're congruent. The little arrows show that they go in both directions forever, making that those two sides are parallel. If I start with the formula, it's area equals base 1 plus base 2 divided by 2 times the height. I have base 1, which is 8. Let's see if I get the right number this time. The trapezoid. Base 2 is 7. We cut that in half, and we times that by the height of this trapezoid, which in this case is 3. I'm running out of room here. 15. We'd have 15 divided by 2 times 3. 15 divided by 2 is 7.5. We have 7.5 times 3. Well, 3 times a half is 1.5. 3 times 21, or 3 times 7 is 21. So I have 21 plus the 1.5. I believe this gives me 22.5. I could tell by these markings here, this is another trapezoid. Start with the formula. I'll start over here. We have area is equal to 1/2 Oh, sorry. Not 1/2. Oh, I guess I could do 1/2. Times base 1 plus base 2 times the height. Looks a little different, but again, when I divide by 2, it's the same as multiplying by 1/2. Doesn't change the answer. I'm going to add 6 plus 4 times that by the height, which is 3, but I have to multiply by 1/2. Let's go. 6 times 4 is 20. Or 6 plus 4 is 10. We times that by 1/2, and then times that by 3. Half of this would give me 5. 5 times 3 is 15, and we have 15 square meters. This next one. What do we have here? Now, I do not see the parallel markings here. A little concerned, but I also do not see any tick marks showing congruency. I am then going to assume it is a trapezoid. I will go base 1 plus base 2 divided by 2 times the height. Base 1 is 2. Base 2 is 3. Divide that by 2 times it by the height, which in this case is 3. The height is 3. That gives me 5 halves times 3. Well, 5 halves is the same as 2.5, I believe. 2.5 times 3. Well, 3 times 1/2 is 1.5. Plus the 3 times 2 is 6. So 6 plus 1.5 gives me 7.5. And I am good to go. Hope this helps you out a little bit with finding the area of trapezoids, rhombi, and kites. And again, excellent video right here to utilize to help you understand a little bit more about area of a kite. I will play this video also in class. It's also going to be posted to the blog. Take care.